Math 1314, Tyler Junior College, section 5.1, 2x2 linear systems of equations. Determining if an ordered pair is a solution. In the previous video, we introduced the terminology when describing a system of equations. And I mentioned that sometimes what you do with the system depends upon its size. A 1x1 system we would solve. A 1x2 system we would probably graph. And I mentioned that a 2x2 system we would solve, but what exactly does that mean? Well, when you're solving an equation, you're looking for values of the variable that makes the equation true. But when you're solving a 2x2 system, two equations with two variables, you're looking for values that make all of the equations true simultaneously. Before we go tracking down solutions, let's verify whether or not an ordered pair would be a solution for a given system of equations. Let's start with the system, a 2x2 linear system, y equals 2x plus 3 and y equals negative x plus 6. Is the ordered pair 2, 7 a solution? We are working under the convention that in an ordered pair, the first coordinate is the x and the second coordinate is the y. So, to see if 2, 7 is a solution, we just have to let x equal 2 and y equal 7 in each equation and see if it makes both of them true. Starting with the first equation. If we take the first equation and substitute 7 for the y and 2 for the x, we get 7 equals 2 times 2 plus 3. True or false? Doesn't take too long to see that this one is true. 2 times 2 is 4. 4 plus 3 is 7. So we're good on the first equation. But to be a solution to the system, you have to make every equation true simultaneously. So now let's check 2, 7 in the second equation. If we substitute 7 for the y and 2 for the x, we get 7 equals negative 2 plus 6. Last time I checked, negative 2 plus 6 was not 7, it's 4. In order to be a solution, you have to make all equations true simultaneously. This one failed to do so. Therefore, the conclusion that we draw is 2, 7 is not a solution to the system. It's not a solution. It made one equation true, but not all of them, and it must make all of them. What about 1, 5? Well, let's try it again. We substitute 5 for the y in the first equation, and 1 for the x in the first equation. We get 5 equals 2 times 1 plus 3. Well, 2 times 1 is 2, plus 3 is 5. So yes, the ordered pair makes the first equation true, but we have to check the second. If we substitute 1 for the x and 5 for the y in the second equation, we'll get 5 equals negative 1 plus 6, which is true. Negative 1 plus 6 is equal to 5. Since 1, 5 makes both equations true simultaneously, the conclusion that we can draw is that 1, 5 is a solution to the system because it's a solution to each individual equation. Let's try one more. You may notice that these are the same ordered pairs that I tried in the previous example, and that the first equation is the same, but the second one is different. It's 4y minus 8x equals 12. Be very careful when substituting into the second equation because the y precedes the x. Just be careful. If we substitute 2 and 7 into the first equation, we'll get 7 equals 2 times 2 plus 3. But just like over there, that's still true. If we substitute 2 and 7 into the second equation, carefully, we get 4 times 7 minus 8 times 2 is equal to 12. And that one may not be as obvious. 4 times 7 is 28. 8 times 2 is 16. 28 minus 16 is 12. So yes, we'll just answer this. Yes, it is a solution. What about 1, 5? Well, again, this is the same ordered pair as before and the same first equation, but just just doing the problem independent of the previous one. If we substitute 5 for the y and 1 for the x, we get 5 equals 2 times 1 plus 3, which is still true. In the second equation, if we substitute 5 for the y and 1 for the x, we get 4 times 5 minus 8 times 1 equal to 12. And it doesn't take too long to see that this is also true. We get 20 minus 8, which is 12. So the answer to this one is also yes. Interesting. Both of these are solutions. So to verify if an ordered pair is a solution to a system, it boils down to just substituting the values for the correct variables. If it makes every equation in the system true, then the ordered pair is a solution to the system. Otherwise, it is not.